Good morning, everyone. Today is CS 746, April 28, and we are going to discuss about artificial neural networks. This is actually out of syllabus as we have a lot of time and we completed the syllabus, before the deadlines. We thought to introduce just an introduction about artificial neural networks, so that if you take any other, like deep learning subjects or data science subjects, then you will find, the basics very easy. So before going into the chapter, uh, do anyone have any doubts related to project? Because the deadline is on May 2nd, I think, and I already uploaded the IEEE sample format paper on the Blackboard, so you can find it. And you need to prepare the report according to that sample report. Okay, so let's start the class. We all know that artificial neural networks, like most of the data science or researchers use artificial neural networks compared to the traditional deep learning models or like machine learning models. So what is the history behind the artificial neural networks? uh, because the artificial neural networks are designed from the biological neurons, uh, that is the neurons that the humans have. So that is the main inspiration behind building artificial neural networks. So this is in simple, we can perform each task easily compared to any machine. Like for example, even though the technology is highly increasing day by day, whatever the tasks that we can perform are good compared to the tasks performed by the machines. So based on this experience, researchers thought that it's better to develop the machines exactly the same way that humans will think. So one way to build the intelligence to the missions is just to try to imitate the principles of the human brain. So let's discuss a short about human brain. Human brain is highly complex, nonlinear and parallel computing composed of 10 to the power of 11 neurons. So if you consider our brain system, the neurons are highly densely connected. So if you consider a single neuron, there are nearly like 1,000 connections per neuron. So based upon these concepts, the artificial neurons are built. And if you consider a simple neuron, basically the neuron is much slower. The performance of the neuron is much slower than compared to the performance of a silicon gate. So if you consider a single logic gate of a silicon, so the performance is 10 power minus 9 seconds. But if you consider the performance of a neuron, it is 10 power minus 3 seconds. So the performance of the neuron is very less compared to the performance of a silicon gate. So, however, so as the performance is slower, then we have a doubt then how the neurons are performing with a high, you know, like high speed. So it's because of the densely connection between the neurons. Because if you consider the brain, we have a lot of densely connected neurons. And that is the reason, even though the performance of a single neuron is very slow, but if you consider a group of neurons, the performance is very high. And we have a rule that is 100 steps rule. So what is the concept of this 100 steps rule? So if you consider a neuron and you assign a task to the neuron just to perform the calculation. So researchers are saying that whatever the calculations that the neuron is performing in order to complete the task, it is not less than the 100 steps. So that is 100 steps rule. So the calculations are always less than the 100 steps if you consider the calculations of a neuron. And what is plasticity? So plasticity is a concept that in our childhood, like when we born, like when we are an infant or a baby, the brain is not developed fully, right? So if we like for year by year, so when we develop gradually, like biologically, then the development of the full brain will occur. So that is what the plasticity means. So we develop the brain with the help of the knowledge and experience. that we are developing day by day. So in the same way, artificial neural networks, they will take the data, like they will take a lot of data, and they will start learning from the knowledge of the data, and they start, improving the model. So like if you consider a biological neuron, a variety of different neurons exist. For example, if we consider our body, we have different neural connections and different neurons for different tasks. Like for example, if you are doing like walking, like particular set of neurons will act. And if you are dancing, then particular set of neurons will perform that task. So we have different neurons that exist in our body, and each perform related to the task that we are doing. So the connections of the network and the strength of the individual synapse, they establish the function of the network. Like for example, if you consider two neurons, the connection between the two neurons, we call it as synapse. And the much the synapse, the greater is the connection between the neurons of a network. So this is how a biological neuron looks like. So it seems to be a biological class. So, but it's very important to understand the parts of a neuron so that you will understand like how a artificial neuron is built. So if you see this, so these are the dendrites. Okay. So these are the dendrites. So what is the function of the dendrites? So they are the nerve fibers and they carry the electric signals to the cell. And if you consider the cell body, so it computes a non-linear function of its inputs. And if you consider the axon, so it is a single long fiber and it carries the electrical signal from the cell body to the neurons. So this is the axon and this is the cell body and these are the dendrites. And this is the synapse. So which we already discussed, like it is a connection between one neuron to another neuron. So based on this concept, in the same way, the artificial neural network is built. So like how our biological neuron will represent the actual artificial neural network. So this cell body is the function that we are applying in building the artificial neural network. Like for example, if you consider the code of any artificial neural network like CNN or RNN or like any deep neural network, we will include some functions like a sigmoid function, activation function. So those are developed based on the concepts of the cell body. So by observing the cell body part of your neuron, the functions of the artificial neural network is developed. And synapses are just the connection between the layers. So if you observe the artificial neural network, like any neural network, we have input layer, hidden layers, and output layers. So those are developed based on the concept of the synapse. So now coming to artificial neural networks, these are completely like inspired by the human brain. So they did not consider any other animals or any other living organisms brain structure. But whatever the artificial neural networks that we are dealing in nowadays are completely developed based on the idea of the human brain. So they are a massively and parallel distributed system. So they made up of simple processing units called neurons in the same way like the biological neural system. And synapse connection strength among neurons, and they are used to store the acquired knowledge. So in our brain, the connection between one neuron and another neuron is done by the synapse. So in the same way, the artificial neural networks, in that we will build several layers and all the layers are connected. And in that way, they acquire the knowledge from the data that we are giving. And knowledge is acquired by the network from its environment through a learning process. So as we all know that ANN or like any artificial neural network is data hungry. So we will provide a lot of data to the neural network and they will start learning from the data like step by step. And that is the reason like if you build a base model of any artificial neural network, you will get like a little accuracy or very low accuracy. But once you change the parameters inside the architecture of the artificial neural network, the accuracy will be increased. So, which means that you are changing the learning parameters of your network so that the performance of the model will get increased at the end. So this is what acquiring the knowledge step by step and improving the model. So coming to the properties of artificial neural network. So what are some of the properties of artificial neural network? First thing, if you consider regarding the data, there is labeled data and unlabeled data. In labeled data, uh, like if you have the label data, it comes under like supervised learning. If you talk about machine learning models, if your target variable has some label, then we will consider it as a semi like supervised learning. So if if you don't have the target variable in your data set, then it comes under unsupervised learning. Then we prefer like algorithms such as clustering because we don't have the target variable label. So in that way, for the data, we have like labeled and unlabeled. Like for example, if you consider the project data sets, so like for some project data sets, there might be a target variable, like you have the label. Like for other sets, like there is a chance that you don't have the label for your target variable. So that is what the labeled and unlabeled means, just describing about the data. And what is adaptivity? So just changing the connection strength to learn the things. So like we discussed before, you build the basic like CNN or RNN, and you observe that the performance is not good. It's not performing very well. Like you got the accuracy like 10% or like 20%, and the precision recall F1 score, those are like very low. So what you will do, you will change the parameters, you will change the learning parameters, like you will change some functions in your architecture so that the model will change the connections between the layers and it will start learning the data very well. So that is what the non-linearity means. The reason that we have non-linearity in artificial neural networks is because, like, if you observe any data, like the output is not the linear, right? Like it's simply nothing but you gave the input like X and you got the output. But like most of the cases, like 90% of the cases, the relation between the input and the output won't be linear. Like definitely it will be a non-linear. Like for example, if you consider like IMU sensor data, which is completely non-linear and has some complex patterns as it is sensor related data. So it's always important to include non-linearity in your models instead of linear. And that is the reason at the base itself, like developing the artificial neural networks, they include non-linearity instead of linearity. And next, fault tolerance. So if one of the neurons or connections is damaged, as we have a lot of neurons and they are like highly connected. So like what happens if one of the neurons or connections is damaged, then the whole work still, I mean, the whole network is still works. So the artificial neural networks are developed, including this concept also, like fault tolerance. And so these are the main concepts that are involved in the developing of ANN, and those are the reasons behind including the these layers in artificial neural networks compared to other functions or other layers. So these all are developed based upon the concept of biological neuron. So like neural model and network architecture. So this is simple, like this is how a simple artificial neural network is given. So these are the inputs like X1, X2, X3, and so on. So these are the inputs that we basically give to the to the model. And for every input, like we consider these inputs can be features in your data set, and we will give weights to the inputs so that in that way we will give the feature importance to the model. So we can give like W1 if it is like 5 and W2 if it is 10. Then X2 has some more feature importance compared to the X1. So in that way, with the help of these weights, we will give the feature importance to the model. And next, the bias is included. So the reason that we include the bias along with these input features and the weights, The reason that we include bias is basically we want our model to fit along with the data. Like the model should learn the patterns in the data. So in order to provide flexibility for your model so that your model will turn according to your data. So to include that flexibility, we introduce bias to our models, and we will include the activation function, and this will be the output. So this is how a simple neural network is built. So we have the output and we have the input, and this is the inside mathematical stuff that we include while building any neural networks. So these weights are changed based upon the performance of the model. So if you think that you build a model by considering a little like the weights as a first try, and the performance is not good. So we discussed that we changed some parameters in the architecture of the neural network, right? So what we basically change, so we can change the weights so that the feature importance can be varied and the performance of the model can be increased. And so these weights you can consider as a connection as we are giving these weights to the input. So this is just a mathematical function representing the output. So AI is basically the output that we got from the artificial neural network. And we will calculate the f of ni. So we will consider the function. And this is in simple, it's nothing but you will consider the inputs and the weights with respect to that input. Because for every input, we have a single weight. If you consider x1 as an input, the weight of the x1 will be w1. And if you consider x2, the weight will be w2. So in that way, we will sum all the weights like x1 w1 and x2 w2, and we'll sum all the weights, and we will add the bias just to introduce flexibility to your model so that it will fit according to your data. So if you don't introduce the bias, the model won't get the flexibility, so it won't fit according to your data, so the model won't perform well. Without the bias, the models are linear, so just the input and the output, and the performance of the model, if you see any graph without including the bias, it will be just linear. So, and bias can be incorporated as another weight that just discussed now, that weights are given with respect to the bias, and the whole function is passed to the model, and we will calculate the output. And so let's discuss about these activation functions. There are several functions that we include while building any artificial neural network. Like for example, if we consider CNN, like convolution neural network, which is basically used for image classification, and recurrent neural network, we basically use recurrent neural network if we want our data to be remembered. Because if you observe that recurrent neural network, there will be loop, like the output of one class is given to another class. So based upon the neural network that you are building, so we will include different activation functions, and these activation functions, like there are several like linear and sigmoid. So these functions we basically um, discuss in our like high school, like in the mathematics, we can see this kind of functions. So if you consider linear, if you consider A as an output and N will be the input, just the performance will be linear. So whatever the input you will give, the relation between the input and output will be linear. So the graph simply passes through the origin. So if you consider the linear function. And what happens if you change the function from linear to like threshold? So you will fix one threshold. So you will consider like a equal to 1 if n greater than or equal to 0, and 0 if n less than 0. So this is the graph that you will get for different conditions of n. So for n greater than 0, you will get all one values for any input. And for n less than 0, we will consider like we will get 0 for all the input values. So this is how the threshold function will work if you apply threshold functions in building your model. And sigmoid, so sigmoid function, this is the like uh, the formula to calculate the output. And this is the graph that how the sigmoid function will looks. And the thing is, this sigmoid curve is simply like the S-shaped curve. It is basically seen if you build the logistic regression. In logistic regression, we will get like S-shaped curve. So it is simply nothing but the sigmoid functions. So in that way, we will include different kind of functions based upon the requirement of your model. So actually, while building any neural network, you are building the layers, like you will provide the input layer, hidden layers, and the output layers, and these functions. So based upon the requirement of your output. So those are completely different from machine learning models, because if you consider machine learning models, there are like linear regression, logistic regression, and like there are like clustering. So compared to those traditional models, it's always preferred to build neural networks. So the performance will be good. But the only drawback of building or the requirement of an artificial neural network is they are data hungry. So you need a lot of data in order to build any neural networks. So coming to another activation functions. So we just discussed about linear, threshold, and sigmoid. But there are like several functions which you can find if you search in Google. You can find like several functions, and based upon your problem, like problem statement, you can use different functions and change the functions based on the requirement. So if we consider like hard limit function, so this is the input and output relations, like a equal to 0 and a equal to 1. Those are only the two outputs that we will get if you consider the hard limit function. And the icon, it shows how the graph will look, and the MATLAB function. So if you want to implement ANN in your MATLAB, if you want to build any neural network in your MATLAB, and in order to use that function, we will use uh, like this MATLAB function like hard limit. And next, coming to a symmetrical hard limit. So this is the name of the function, and this is the like input and output relations if you consider this function in your model building. So we have a equal to -1 and a equal to +1. So only two values for the output, like -1 and +1. So the graph will lies only between -1 and +1. So this is how the graph will look for the symmetrical hard limit. And this is the MATLAB function like hard limits. And linear, uh, we just discussed now. So, and there are like several like linear, symmetric, and sigmoid. In sigmoid also we have like log sigmoid and hyperbolic tangent sigmoid. So there are like several functions. You can just read like when you have free time, so that you will understand like how the performance of the model is varying based upon the functions. So you need not to build like a complete model. Just start building the ANNs, like any neural networks, with the data that you have, so that you will get familiar like how the performance of the model is, it is changing with respect to the functions. And another important, like how the artificial neural networks represents the like human brain. So even though the ANNs are completely built based upon the idea of like biological neuron, in simple like human brain, so how it is, representing the human brain. So it is exactly representing the human brain in two concepts. One is knowledge is acquired by the network from its environment. So if you consider like our brain, so it is not fully developed when we are born. So like when we are in at the age of 1, 2, 3, the brain starts developing step by step. So in the same way, the artificial neural network, so once you build, it start developing, or it start improving based upon the data that you provide. So it start taking the data and it start improving. And so this is the example, like for example, if you consider like ChatGPT, just previous like few days back, we have like one important uh, concept, that is Ghibli Act or something. Yeah, right. So the reason that they developed because you guys will give like lot of images to that model. So the model got trained by lot of data. So in that way, the model got improved. So that is a process. Like if you build a basic model, you'll start improving it by providing a lot of data. That is how the model will learn step by step. So, and the synaptic connection strength. So another point, like how the artificial neural network represents the human brain is they have the synapse connections. So in artificial neural network, we have a lot of layers that we build. So there will be the stronger connections between the like between the layers. In the same way that we have in our like human brain system. So we have different network topologies. So this is a simple single layer, like there is no hidden layers in that. If you observe this network, we just have input and output. So this is, we can consider as a first artificial neural network. So the first artificial neural network is perceptron. So in that there are no hidden layers, just the input and the output. Those are built based upon the mathematical concepts. Because if you observe the ANN in detail, they're just having the max, right? You are just including the functions, you are giving the input, and you are taking the output. That is what we do in functions. So if you consider a function f of x, so what you will do, you will take the x and you will pass that x to the function f of x, and the output will be y. So y equal to f of x is nothing but uh, a simple neural network. So all the neural networks, those are built from the concepts of mathematics. So if you want to develop any career related to AI or any neural networks, it's very important to learn the mathematical stuff so that you can build your own algorithms and you can build your own neural networks. And different network topologies. So that is the single layer that we discussed. Just have like input and output. But if you consider this, just the hidden layer is included, like input and hidden layer and output. So this is the multi-layer like feed forward network. And this is RNN in recurrent neural networks. These networks are basically built if you need your model to remember something, like for example, time series data. If you want to predict t plus 1 and you need information at t in order to predict t plus 1, like what we do in stocks, like if you want to predict something in future, they need information from the past. So in such kind of cases, if you want to build such kind of models, we use RNN. So this is the structure that is behind the RNN. So if you observe the output, uh, if you consider this as output 1 and this is as output 2, the output 1 is connected to the output 2 and 2 is again connected to the 1. So we have a loop, like feedback loop to this system. And applications of ANN, ANN is basically used in various domains. So if you observe any research paper, they will definitely consider neural networks for the comparison. Even though they have built any machine learning models as their final model, they will definitely consider neural networks for their comparison, and they will say that my model performed well compared to this model. So ANN is considered in, like neural networks are considered in every research, like in nowadays. And function approximation and for memory, this is related to RNN. Like if you want to remember, like if your model want to remember any information, then you can prefer. So artificial neural networks. So the first artificial neural network is perceptron, the one that I discussed at the beginning. They just have only input and output and no hidden layers. And Adeline is nothing but perceptron is linear, because if you consider the perceptron graph is just y equal to mx, we have the input and the output. But if you consider Adeline network, it introduced the non-linearity to your model so that the performance of your model is good, because we are not using the linear networks nowadays. Like whatever the basic model that you build on any data sets, they are designed to handle the non-linearity in your data. So linearity is nothing, is like it's just over. So we are not including any linearity models in our data. And Hopefield network is nothing but if you have the like feedback loops to your model. So RNN comes under hope field network, and like whatever the non-linearity models that we built, it comes under Adeline. So just a single neural network without any hidden layers, it comes under Perceptron. So, and current models, so deep learning architectures and multi-layer feed-forward networks like multi-layer perceptron and radial basis function networks and self-organizing networks. So these are some of the current models related to the artificial neural networks. So based upon your requirement, like which network I need to choose. So for example, if you are doing image classification, you can prefer convolution neural network. And if you want to predict like some time series related information, so you will prefer RNN. So based upon your requirement, you will choose number of input layers, because neural networks are something that you are designing. You will design the input layers, you will design the hidden layers, you will design the functions. So you should have all the information like in your hand, so that you can design whatever the network that you need. So if two persons are given the same data set and just said to build whatever the neural network that you want, those two persons can build different neural networks. So based upon the understanding of your data they have and the knowledge of the building of ANN. So multi-layer perceptron, each layer may have different number of nodes and different activation functions, but commonly same activation function within one layer. So this is basically how you consider the input layers and how you consider the activation functions, and you can consider two or more activation functions. So based upon how you want your model to be performed. So you can simply try, just consider a simple data set, whatever the data set that you have, and start building basic CNN and deep CNN and observe the performance. Definitely, if you include more layers and include some activation functions, the performance will be increased. So, and neural network resources, there are some very good books if you want to learn about neural networks. So these are the main textbooks. Like if you want some more information related to the neural networks, you can include like neural networks, which is a foundation. And this book is very related to theoretical. Like if you don't have any knowledge related to neural networks, just consider any books that will teach some theoretical concepts so that you will get some interest, because mm, developing knowledge in ANN is not that easy. You should get some interest. So just if you have some time and if you are interested in learning about the neural networks, just prefer these textbooks. These slides I already uploaded in the Blackboard, so you can just search in the Google and just found the books. And there are some special books related to the pattern recognition. So if anyone want to learn about pattern recognition, so you can read the book specific to that area. And coming to practical, so first read the theoretical books or prefer the theoretical books if you want. And next, coming to the practical books, there are practical neural network recipes in C++ and seminal paper. So, and there is some more tutorials like deep learning book. Actually, there are a lot. I just pasted only one. So this is in simple how the neural networks. But coming to one more interesting area is robotics. I don't know like how many are interested in robotics. So whatever the models, even though the neural networks, like nowadays the researchers are saying that the neural networks are also the traditional models. So they are shifting to like symbolic models. So I did not included slides related to symbolic models, but I will explain you in short. So we discussed about machine learning models. We discussed about neural networks, but the trend is going towards the symbolic models. In symbolic models, you will provide knowledge to your models, because if you consider a neural network, you will simply consider the data and build the model, but you are not providing any knowledge to your model. For example, if you consider the medical field, in medical fields, we'll consider the data and we will build the model. But the doctors are asking that how can we trust the results of your model, because that models are not trained with the help of domain knowledge. They don't have any knowledge related to medical field. So based on these concepts, the trend is going towards symbolic models like symbolic AI. In that, we will include the domain knowledge to the models. So with the help of rules, so we will include the domain knowledge. So in that way, the performance of the model will be accurate. Like you can get even 100% accuracy for such kind of models, as the results will be accurate. So so this is in short related to the traditional models, which we already discussed in previous class, the entire semester, and a short introduction about neural networks. It's very important to learn, like whoever in the starting stage of the masters, if you want to develop, because if you have like 1.5 year of time, so you can definitely develop stuff related to neural networks. And if you have time, just explore like symbolic AI. You need not to discuss, like you need not to learn a lot, but you just have some knowledge, because there are like several internships opening in the robotics area too. So that's all for today class. We are all done, and there is no attendance for today. And before ending the class, any doubts related to the project, because many students came after the start of the class. So just submit according to the instructions. Don't miss any part. So we don't want the accurate results, but you need to include every part. And the figures should be included from the code, because we will find like several documents. The code will be different, the report will be different. So please don't do that. You will get, like, I think if you do such kind of things, you will get like only 10 or 5 marks for that whole project. And project weightage is 35%. So please concentrate on that. Uh, yeah, that's it. Uh, if you don't have any doubts related to the project, or and coming to the final, I will prepare one more lecture related to the final. So whatever the concepts that we are going to discuss in Wednesday class. So after that class, I think we will have like one more class. At that time, if you have any doubts related to the final, you can just ask me or Ajay or professor. So just send us an email so that you will find final easy. So just concentrate on the final. It's very important to get like A at the final. Okay. Thank you. That's all for today.